Voyager 1, NASA's most distant rocket, continues its amazing journey through space, seamlessly transmitting vital information from the deepest parts of the universe for nearly 50 years. This phenomenal space probe changed our understanding of space. Recently, however, a spacecraft sent disturbing information back to Earth, leaving the entire space industry in shock. Are these disturbances the result of technical failure or extraterrestrial activity? Join us to discover the reality of these amazing shows. Since the beginning of recorded history, scientists have been fascinated by the mysteries beyond our celestial borders. This interest led to the historic launches of the Voyager 1 and Voyager 2 spaceships, among other important space missions. These important missions began with the launch of Voyager 2 from NASA's Kennedy Space Center on August 21, 1977. 14 days later, on September 5th of the same year, Voyager 1 followed suit. The two probes, each weighing a remarkable 720 kilograms, comparable to a small car, were thrust into space during a rare alignment of the exoplanets. During their amazing odyssey, these intrepid travelers sailed in different directions and at different speeds, leading to the decisive moment on December 15, 1977, when Voyager 1 passed its identical twin as their paths diverged. Since then, Voyager 1 has become a great asset, providing us with a wealth of information and revealing the mysteries of space. Before we delve into Voyager's surprising new discovery, which stunned the entire space industry, we should revisit the extraordinary images that the rocket captured on its landmark Jovian imaging mission in 1978. Some 265 million kilometers from the Earth, Voyager 1 sent back an astonishing number of images of Earth. In January 1979, it began a 100-hour project, capturing mesmerizing time-lapse film showing 10 orbits of Jupiter. A cornucopia of 3,750 images allowed us to see Jupiter's magnificent dance in vivid detail. In the following months, Voyager 1 explored the Jovian lunar system and made the surprising discovery of a small ring around Jupiter and two new moons, later called Thebes and Métis. This has broadened our understanding of Jupiter's fascinating region. Corrective maneuvers were made to ensure safe passage and avoid a possible collision with one of Saturn's moon Titan. Voyager 1 continued its celestial journey around Saturn and revealed 4 more moons: Mimas, Enceladus, Tethys, and Dione. At the culmination of the Saturn mission, scientists decided to push both Voyager 1 and Voyager 2 beyond the limits of our solar system, hurtling through space at an amazing speed of 325 million kilometers per year. In January 1990, the second chapter began, the Voyager interstellar mission. At that point, Voyager 1 produced some of the most iconic photographs in history, capturing the Sun and most of the planets. One person who played an important role in expanding the missions beyond their original goals was the eminent astronomer Dr. Carl Sagan. As part of the Voyager mission imaging team, Dr. Sagan passionately advocated that the final set of images be taken as a farewell gift to humanity. In contrast, his steadfast determination paid off on February 14, 1990, when Voyager 1, 6 billion kilometers from the Sun, began a visual tour known as the Family Photo of the Solar System. These stunning images, 60 in all, add to a remarkable collection of 670 photos of the shuttle during its encounter with Neptune. Voyager 2 achieved the extraordinary feat of recording wind speeds in excess of 13,100 meters per second, making it the fastest wind ever documented in our solar system. As the spacecraft ventured 280 miles into Neptune's blue, methane-rich atmosphere, it provided us with spectacular views of this distant celestial body. In particular, Neptune's largest moon Triton was found to be one of the coldest bodies in our solar system, with surface temperatures down to a chilly -391 degrees Fahrenheit. Triton's strange features, such as ice volcanoes that ejected frozen particles 5 miles into the murky atmosphere, also blew our minds. These extraordinary discoveries have expanded our understanding of the immense diversity and complexity of the celestial bodies that inhabit the outermost regions of our solar system. The Voyager 1 spacecraft has just made one of its scariest discoveries. In particular, What he has achieved in the last 45 years will be investigated. The achievements of Voyager's twin probes were quite extraordinary. More than 4 decades ago, their initial observations of the moons of Jupiter and Saturn stunned scientists and shattered previous assumptions about these distant worlds. These moons, once thought to be inactive and heavily scarred like our moon, have turned out to be teeming with geological activity. Voyager 2, in particular, made several extraordinary achievements during its journey. It made history in 1986 when it became the first spacecraft to fly near Uranus. Only 3 years later, another important achievement was realized with a flight of Neptune. So far, it is the only spacecraft that has undertaken such a journey. As the Voyager spacecraft continued their journey, NASA implemented various measures to extend their life. In recent years, unnecessary parts and heaters have been removed to save energy, ensuring that these brave explorers can continue their missions in the next decade. Their estimated mission end date is 2030. For the scientists and engineers involved in this remarkable project from the beginning, the culmination of the Voyager missions is both a moment of pride and a touch of melancholy. Their unwavering commitment and passionate efforts exceeded their initial expectations. The wealth of information returned by the travelers has provided valuable insights, fueled countless scientific discoveries, and ignited the imaginations of countless scientists and space enthusiasts. Voyager 1 and Voyager 2 were no ordinary space probes. They were carefully designed to be stable platforms that rotate more than 15 times slower than the hour clock. This design decision reduced visual blurring as the spacecraft captured images and data as it traveled through the infinity of space. Even before their encounters with exoplanets, their impressive imaging capabilities began to amaze scientists and the public. The spacecraft began sending images of Jupiter before it reached the gas giant. These early images, featuring swirling clouds and the iconic Great Red Spot, delighted audiences at NASA's Jet Propulsion Laboratory. But the discovery of active volcanoes on Jupiter's moon Io really came into the spotlight. An object slightly larger than Earth's moon has turned out to be the most volcanically active body in our solar system. The spacecraft's instruments detected the strange signals from Io, confirming the characteristic images they captured. High volcanic clouds and a surface scarred by volcanic eruptions appeared. One of Io's most prominent volcanoes erupted with 10 times the force of St. Mount Helens, covering an area almost the size of France. Although the spacecraft's cameras were later shut down to conserve power and memory before the trip to interstellar space, it is notable that the photos they took did not include Mercury and Mars for various reasons.
In addition to the interstellar probes Voyager 1 and Voyager 2, NASA also operated other notable spacecraft such as Pioneer 10, Pioneer 11, and New Horizons. Voyager 1 passed Pioneer 10 on February 17, 1998, making Pioneer 10 the most distant spacecraft. Voyager 1 continued its solitary journey for another 14 years before finally entering the interstellar medium on August 25, 2012. Although no other spacecraft were seen, NASA did not publicly announce this remarkable achievement until 2013. What are the procedures which ensured the success of Voyager's mission? During Voyager's incredible missions, one method stood out particularly brilliantly: gravity assist maneuvers. These maneuvers played an important role in launching Voyager 1 and Voyager 2 on their daring mission to explore the outer regions of our solar system. To reach these distant destinations and gather valuable information, spacecraft needed more than just their propulsion systems. They needed thrust, and gravity assist provided just that. Imagine 2 intrepid spacecraft, Voyager 1 and Voyager 2, undertaking their spectacular tour of the solar system. Instead of relying solely on their engines, they danced the celestial dance with some of the heavy planets of the solar system. This incredible dance allowed them to take advantage of the immense attraction of these giants to shoot themselves down the road. In turn, they could save valuable fuel and gain the necessary speed by visiting different destinations. Let's learn the basics of gravity assist, also known as gravity slingshot. The idea behind this motion is to transfer some of the planet's energy to the spacecraft as it passes by. Image Voyager 1 approaches Jupiter, a massive gas giant with a similar gravitational pull. Jupiter eroded Voyager 1 with the utmost precision at the perfect angle and speed. Jupiter's gravity pulled the spacecraft, accelerating it to higher speeds and giving it considerable thrust. Performing a gravity assist maneuver requires exceptional precision. Had Voyager 1 approached Jupiter at the wrong angle or speed, the slingshot could have deviated catastrophically from its intended course. The level of precision required is daunting, but the brilliant minds behind these missions have successfully performed these gravity assists several times, setting the Voyager spacecraft on an amazing journey through the solar system. Voyager 2, for example, used Jupiter and Saturn gravity aids to reach Uranus and Neptune. These celestial movements were very important in making the Grand Tour possible. The Voyager missions owe much of their success to these gravity assist missions. Voyager 1 continued to reach interstellar space, and Voyager 2 followed quickly behind, all thanks to the precision of their maneuvers.